I'm going to do today is I'm going to show you how to get working on the week 12 lab, which is right here. We'll create a new document in our week 12 folder. We're going to title it Modeling Atoms and Ions Lab. So let's get working. And then we will generate a table with 15 rows, and then in each row we'll do these things. What I'm going to do right now is I'm going to copy and paste, or I'm going to copy this stuff anyways, Command C. I'm going to go into my drive. I'm going to create a new document, create and share. Wait for it to load. I'm going to retitle this document Modeling Atoms and Ions. And then here's where I'm going to create my table. Table, insert table, needs to have 15 rows, so it'll be a 1 by 15 table. This is where we're going to type in our information. Remember, for the lab, Command V, I copied the important information. Write the symbol of each element or ion on the board in the first line. So on this line, what I should do is write my first symbol. In this case, it's for magnesium 22. So we would write as a superscript, Command period 22. Sorry, Command Z. I'm going to zoom in real fast for you so you can see a lot better. Alright. Command period gets me in my superscript 22. Command comma makes a subscript 12. Command comma gets me out of that. MG is my symbol. Command period, my charge 2 plus. Interpret the notation to define the number of protons, neutrons, and electrons. So now I need to use that notation and do what it says. So for the number of protons, that is always the same as your atomic number. The subscript there is your atomic number, so the number of protons is 12. The number of neutrons, that comes from your mass number. The superscript before the element symbol is the mass number. Recall that mass number is protons plus neutrons. So 22 equals 12 plus what? 12 plus 10 gives me 22. So there should be 10 neutrons in this case. And finally, electrons. Electrons come from the charge, and this superscript identifies the charge. So plus 2 equals 12 minus how many? 12 minus 10 gives me positive 2. So in this case there are 10 electrons as well. Alright, so now I've interpreted the notation to identify the number of protons, neutrons, and electrons. So I get rid of that. On the third line, write the full electron configuration. So 1s, command period 2, command period 2s, 2, 2p, 6, 3s, 2. That's the electron configuration for magnesium most of the time. However, in this case we have only 10 electrons because this is an ion. This is a cation. It's positively charged. Since it's positive charge, it doesn't actually have 12 protons and 12 electrons. In this case, it only has 10 electrons. 2 plus 2 is 4, plus 6 is 12. 2 plus 2 is 4, plus 6 is 10, plus 2 more is 12. But in this case, we don't have those electrons because we lost 2 electrons. That's why we have a positive charge. This is the electron configuration for magnesium in this case. Just finished that because it's an ion. On the fourth line, write the noble gas notation. So now the noble gas notation based on this. In hard brackets, helium, and then whatever we had to add on. Command C, Command V. So this is a noble gas notation. Notice this is the exact same electron configuration as neon. All right, that's on purpose. And last but not least, insert a snapshot of the model you constructed of the element. So we need to construct a model very quickly, and then insert an image. The way you do that, insert, image. Click on take a snapshot. Allow it. And you'll see we're about to take a snapshot. And what I have is my work here. It's blank right now, but I'm going to go ahead and build my magnesium. We have protons, which are red. In this case, we'll need 12 of them. 2, 4, 6, 8, 10, 12. So I have 12 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. And then we need 10 electrons. We'd start in the center. So this is where the nucleus is. It says nucleus on the sides. And that's just like a zoomed in version of where the nucleus actually exists. The nucleus actually exists right here. The electrons go around the nucleus. They begin at 1s, so 1s2. And then you have electrons in 2s, 2s, 2. Followed by 2p, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. And if we were to make normal magnesium, we would have 3s1, 3s2. However, in this case, we have the magnesium ion, which is a cation. It has a positive 2 charge. So what we need to do is remove 2 electrons. Remove those 2 electrons. And now we only have 10 present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Last but not least, let's try to get a nice stable picture. Move my mouse. Take a snapshot. And you can see that it exists over here. And I'll go ahead and select that picture. Looks good. I can just resize it. Go ahead and select the picture. Drag it down. Drag it down some more. And that's what I would do for magnesium. I'd repeat this process for each and every other element. That's all. Hopefully it was clear and hopefully it's useful. Good luck.